Bavaria, Germany. October 1944. Oberingenieur Franz Hartmann stood in the cold hangar at Reckland Test Center, staring at the aircraft before him with a mixture of professional curiosity and dread. The North American P-51 Mustang had been forced down 3 days earlier, its American pilot now a prisoner. The fighter was largely intact, and that made it intelligence gold. For months, Luftwaffe pilots had been screaming into their radios about this silver demon that escorted American bombers all the way to Berlin and back. Impossible range, devastating speed, unmatched agility. Now Hartmann would finally see what made it so deadly. But as he approached the Mustang with his tools and notebooks, he had no idea he was about to discover something far more terrifying than just another enemy fighter. He was about to uncover a truth that would make him realize the war was already lost, not on the battlefields, but in the factories of two allied nations working as one industrial superpower. Franz Hartmann was not a soldier. He was an aeronautical engineer, 38 years old, who had spent his entire career at Daimler-Benz designing aircraft engines. Before the war, he had worked alongside British and American colleagues at international aviation conferences, discussing horsepower, compression ratios, and supercharger designs. He believed in numbers, in mathematics, in the cold logic of engineering. Politics bored him. Ideology irritated him. He cared only about what worked and what didn't. His job at Reckland was simple. Examine captured Allied aircraft, identify their strengths and weaknesses, and provide tactical recommendations to the Luftwaffe. He had examined dozens of enemy planes, Spitfires, Hurricanes, P-47 Thunderbolts, B-17 bombers. Each examination had been enlightening, sometimes disturbing, but nothing had prepared him for what he was about to find inside this Mustang. The P-51 had earned a fearsome reputation. It had appeared over Germany in late 1943 and changed everything. Before the Mustang, American bombers flew unescorted deep into Reich territory, and German fighters slaughtered them. But the Mustang could fly from England to Berlin and back, over a 1,000-mile round trip, while fighting the entire way. It was faster than the Bf-19, more agile than the FW-190, and it just kept coming. German pilots called it Der Honker, the executioner. Hartmann had read the intelligence reports with professional skepticism. Every enemy aircraft was exaggerated by frightened pilots. But the numbers were undeniable. Luftwaffe losses had tripled since the Mustang's arrival. Experienced aces were falling from the sky. The Americans had achieved something Germany desperately needed, a long-range escort fighter that could dominate the skies. Now he would see how they did it.
He climbed onto the wing and peered into the cockpit. The instrumentation was comprehensive but not overly complex. Radio equipment was modern. The canopy provided exceptional visibility, a clear tactical advantage in dogfighting. Everything he saw confirmed what he already knew. This was a superb fighter aircraft. But it was the engine that would tell the real story. Hartmann and his two assistants began removing the engine cowling. It was a methodical process, bolt by bolt, panel by panel. As they worked, he calculated possibilities in his mind. The Mustang's performance suggested an engine producing at least 1,500 horsepower, possibly more. That meant either a massive radial engine, like the American R-2800, or a liquid-cooled inline engine, like Germany's own DB605. Given the Mustang's slim fuselage, it had to be an inline. The cowling came away, and Hartmann found himself staring at the engine. His first reaction was confusion. The configuration was immediately familiar. A V12, liquid-cooled inline engine with a distinctive supercharger mounting. He had seen this exact design before. It looked almost identical to the Rolls-Royce Merlin, the engine that powered the British Spitfire. But that made no sense. Why would an American fighter use a British engine? He leaned closer, examining the casting marks and manufacturing stamps. His assistant stood beside him, equally puzzled. Klein pointed to the engine block. "Herr Oberingenieur, look at this." Then Hartmann saw it, stamped clearly on the engine block. Packard Motor Car Company, Detroit, Michigan, USA. For a long moment, Hartmann just stared at those words. His mind struggled to process what he was seeing. This was a Rolls-Royce Merlin engine, one of the finest aircraft engines ever designed by British engineering. But it had been manufactured in America by an automobile company on the other side of the Atlantic Ocean. The implications hit him like a physical blow. He pulled out his reference materials and began cross-checking. The Rolls-Royce Merlin was a masterpiece, producing over 1,500 horsepower with exceptional reliability. It powered the Spitfire, the Hurricane, the Lancaster bomber. It was Britain's most valuable military asset, and somehow the British had given this technology to the Americans, who were now mass-producing it. The level of trust and cooperation this represented was staggering. Hartmann knew that Germany hoarded its technology jealously. The idea of sharing advanced engine designs with Italy or Japan was unthinkable. Each Axis power worked in isolation, protecting their secrets. But the Allies had done the opposite. They had taken Britain's best engine and handed it to America's industrial might. It was strategic thinking on a scale Germany couldn't comprehend. His assistants began a detailed examination of the engine while Hartmann took notes. What they found was extraordinary. The Packard-built Merlin was not just a copy, it was an improvement. American manufacturing techniques had refined the British design. The tolerances were tighter, the materials more consistent, the quality control superior. Components were interchangeable between engines. Klein, who had worked on Daimler-Benz engines for 15 years, made an observation that chilled Hartmann to his core. "Herr Oberingenieur, look at the manufacturing quality. Every cylinder is perfectly matched. This engine was built with unlimited access to high-grade aluminum, steel alloys, and precision tooling. They're not struggling to make these. They're making them easily." Hartmann requested intelligence files on Packard and the Merlin engine production. What he learned made him feel physically ill. Packard Motor Car Company, a luxury automobile manufacturer in Detroit, had been licensed by Rolls-Royce in 1940 to produce the Merlin engine. They had converted their automobile factories into aircraft engine plants. By 1944, Packard was producing over 2,000 Merlin engines per month, with plans to increase to 3,000. He did the mathematics in his notebook. 2,000 engines per month meant 24,000 per year from a single company. Total Packard production would exceed 55,000 Merlin engines by war's end. For comparison, Daimler-Benz, Germany's premier aircraft engine manufacturer, was struggling to produce 2,000 engines per month total across all engine types, and German production was constantly disrupted by Allied bombing raids. But it got worse. The Merlin wasn't just used in the P-51 Mustang. It powered multiple Allied aircraft: the British Spitfire, Hurricane, Lancaster bomber, and Mosquito. One engine design produced in 3 countries, powering dozens of aircraft types. It was standardization and cooperation on an industrial scale Germany couldn't match. Hartmann examined the engine's construction in detail. The supercharger was a 2-stage, 2-speed unit that maintained power at high altitude. He found documentation showing maintenance schedules. Merlin engines were expected to run for 200 hours between major overhauls, sometimes more. German engines were increasingly failing after 100 hours or less, as quality materials became scarce. The Americans were building engines that lasted twice as long, and they were building them in numbers Germany couldn't imagine. It was an industrial avalanche. Skilled workers, including thousands of women, operated precision machinery. Hartmann calculated the engine production ratios.
By 1944, Packard alone was producing more Merlin engines than Germany produced total aircraft engines across all manufacturers. The Allies were winning an industrial war through partnership. Germany was losing it through pride. The result was undeniable. Germany, with its ideology of racial superiority and distrust of allies, had chosen isolation. The Allies, through trust and cooperation, were burying them in aircraft. Hartmann's final report was 47 pages long. It documented the Packard Merlin's technical specifications, manufacturing quality, and strategic implications. His conclusion was devastating. The P-51 Mustang, powered by the American-built Packard Merlin engine, represents a synthesis of British engineering excellence and American industrial capacity. The strategic implications are profound. The Allies have created an integrated industrial war machine that Germany cannot match. The report was sent to Luftwaffe headquarters in Berlin. Hartmann waited for a response. Days passed, then weeks. Finally, he received a brief message from a staff officer. Report received and filed. Recommendations noted. Continue current assessment procedures. That was all. Through informal channels, Hartmann heard the real response. His report had been read by several senior officers who had reacted with anger rather than concern. One general had reportedly said, "This engineer has been demoralized by examining enemy equipment. Our jet fighters will sweep them from the skies." The assessment was filed away and forgotten. Hartmann wasn't surprised. He had seen this pattern before. Intelligence that contradicted Nazi ideology was rejected regardless of accuracy. The leadership didn't want analysis, they wanted validation of what they already believed. When reality contradicted the fantasy of German superiority, reality was dismissed as defeatist propaganda. Silence was safer than honesty. In the months following his report, Hartmann watched his predictions come true with painful precision. P-51 Mustangs appeared over Germany in increasing numbers. German fighter losses mounted catastrophically. Experienced pilots, the irreplaceable aces, were shot down and not replaced. Replacement pilots arrived with minimal training and died within weeks. The Luftwaffe's tactical adjustments came too late. The industrial advantage was too great. For every German jet produced, America built 100 Mustangs. The statistics became overwhelming. Total Packard Merlin production exceeded 55,000 engines.
Total P-51 Mustang production exceeded 15,000 aircraft. The combined Anglo-American production total was over 430,000 military aircraft. German production for the same period was approximately 94,000 combat aircraft. The Allies had produced more than 4 times as many planes. After the war, Hartmann was interrogated by American technical intelligence officers. They asked him directly, "Did you really conclude from examining one engine that Germany would lose the war?" Hartmann answered, "I concluded that Germany could not win an industrial war against an Anglo-American partnership. The Packard Merlin was evidence of strategic cooperation on a scale we couldn't imagine." The American officer showed him production statistics. Total combined Merlin family production from both countries, over 200,000 engines. "You actually underestimated our capacity in your report," the American said. Hartmann looked at the numbers and felt a familiar despair. "Yes, I see that now. I should have trusted the evidence." The interrogator asked one final question. "Why do you think the partnership between Britain and America was so effective?" Hartmann thought for a long moment before answering. "Because it was built on trust. Britain trusted America with their best technology. America trusted Britain's engineering expertise. That trust created cooperation that multiplied both nations' strengths. Germany trusted no one, and so we fought alone. Trust won the war." The story of Franz Hartmann and the captured P-51 Mustang is a case study in how strategic partnerships can multiply industrial power. The decision to license the Merlin engine to Packard was controversial, but the British government understood that survival required American industrial help. They handed over complete blueprints, metallurgical specifications, and decades of knowledge. It was an act of strategic trust. Packard responded by not just copying the Merlin, but improving it for American mass production. Trust had been rewarded with excellence. Germany's failure to build similar partnerships doomed its war effort. The Axis alliance was hollow. Each nation fought alone, hoarding resources and protecting secrets. The Axis lost because it was never truly an alliance. Hartmann's report had been ignored in 1944, but history had proven him right. The Packard Merlin and the aircraft it powered had helped achieve the air superiority that made Germany's defeat inevitable. In the end, the Mustang's success wasn't just about horsepower or aerodynamics. It was about two democracies choosing to trust each other with their most valuable assets, combining their strengths, and working together toward a common goal. That cooperation, more than any weapon or strategy, had won the war.